Hey man,
Yes,
how are
good
things?
afternoon. I'm fine, thank you. How are you?
All good, all good. And really curious to see how you can mess up your system, and also really curious about whether you should do that in production or not. So I guess you'll enlighten us about that.
Yes, definitely.
I hope to hear at least one YOLO.
All right, let's bring up your screen as well, and then I'm gonna remove myself and Rachel from screen, and then you're good to go.
Okay, thank you.
Good luck.
Thanks. Okay, welcome everybody. As said already, I'm going to talk about chaos engineering, unleash the monkeys. Well, I have to disappoint some people maybe because everybody thinks we are going to break stuff, but that's not really the goal of chaos engineering. We might break some stuff, but it's not the goal. And chaos engineering is also not about injecting chaos in production. Again, it's not the main goal. It's not that we're not going to do it, but the goal is not to break stuff. What the goal is, I will talk about it later, but first, let me just introduce myself. My name is Jacob Duijzer. I'm 43 years old. I live in the Netherlands. And actually, I've been thinking about what do I do? I like to help people grow. That's what I've been doing almost all my professional life, giving talks, giving workshops, things like that. And I like to read a lot to get more knowledge, but maybe that's not the most interesting part. So let's just start about chaos engineering and what chaos engineering actually is. Well, it's a discipline. It's not about creating chaos as much as possible and try to break things. Although what they sometimes do, and I think there's some famous talks about Amazon, where they just break cables, they cut cables in their data center, and they do everything to break it. But that's not really what you want to do. You want to do it in a disciplined way. And as this statement says, it's a discipline of experimenting to build confidence. So what you want to do is you want to be sure that your system does what it should do, even when there's some turbulent conditions. And turbulent conditions can be anything from earthquakes to maybe just failing hard disks. There's a very broad spectrum of chaos you can think about. But the main thing is, it is about experimenting, but it's experimenting with a hypothesis in mind. You want to prove that you actually know what you're doing, and when you break stuff, things will still work. So just to recap that again, it's experimenting, but it's carefully applying chaos or failure. Just remove one hard disk, see what happens. See if your hypothesis is correct, and if not, how you can solve issues you just found. And you want to try and find weaknesses and make your systems more resilient. So many people think you just start like a monkey, break things, break cables, break hard disks, whatever you can do to break it. And maybe at the end you could do that, but don't start with just removing cables. And I will talk about how and what we are going to do that, but first, how does an experiment look like? And it's very cool. I hope you all saw just Laila's talk, because he's talking about telemetry, tracing and logging. These are the tools you need, because you want to know your system is healthy before you can apply chaos. So you set the baseline. If you think about like Netflix is doing chaos engineering, they have a baseline. They say every minute a certain amount of people are clicking the play button. That's our baseline. If we are going to apply some chaos or do some experimenting, you should be sure that that baseline doesn't drop down too much. Like if you have 0 starts in a minute, something is wrong. You need to cancel your experiment and make sure everything works again. So you set the baseline, then you create a hypothesis. And the thing is, many people say, they will say, what will happen if I do this? But you should actually say, when I do this, what will happen? Because you are going to do it. Don't say what if. No, you are going to break it at the end. So it's a hypothesis. What will happen if? What will happen when I remove a service? I expect products can still be ordered, or people can still click on the play button, or whatever. All these, this is part of your hypothesis. Logging and tracing, I already said, it's very important because you want to be sure your system is still working. And you only can do that when you have good dashboarding, good tracing, good logging. I also, the same thing as Laila said, it's a very broad topic, so too much to go into details right now. But it's one of the bases you really need. And maybe I will show a bit of it, but not that much. Do state what will happen. So I just say, then you go to test. So you test, is it really true what I said? So I kill the service, and I said it will still serve. Maybe I have a website and I can still order. Is that true? Then at the end you evaluate. Was it really true? Did we find anything else? How are we going to fix it and document it? If it failed, do the test again and repeat until it works. Then there's some things to consider when you start experimenting. The first thing is you have to be careful, especially when you do it in production. If you have a web shop where you can order products, you might want to be sure that people can still order products at all times. So either you do it for a small group of customers, or you do it on a staging environment before you do it in production. But be sure you have a plan to cancel your chaos experiment. So maybe like for Netflix, they say if less than 100 people are starting a new video in a minute, we are going to cancel it. Also prepare a rollback plan and a backup plan. You know, if you kill a service, maybe when you bring it up, it might be difficult. So yeah, really have to have a good plan for getting back into production. And the last part you have to be very careful about is the blast radius. And the blast radius is, if something fails, will it not affect other systems? So for example, maybe when you kill a product service, maybe the order picking process will also stop because they need to find where the product is. And maybe because of the order picking service fails, the trucks cannot go out of the warehouse again. So you have to be very careful that you start small and make sure your blast radius is also small. Don't affect your whole system. Make sure if you kill one service, don't let it cascade failures into breaking down the whole system. There are a lot of different terms for chaos engineering. And when you talk about chaos engineering, it's also maybe not the best term to use. Everybody uses chaos engineering, but it might scare people because everybody thinks, well, chaos, we have not enough chaos in our daily lives. Maybe let's skip this, we won't do this. So there are other terms like Google is using site reliability engineering. Reliability is a very powerful word, much better than chaos. So maybe you can turn it around and start talking about reliability engineering instead of chaos engineering. Especially when you talk to management, when you talk to stakeholders, don't tell them you are going to experiment with chaos, but just tell them you're going to experiment to enhance your reliability. All these terms are kind of related. So SRE, Site Reliable Engineering, game days, which I will discuss later on also, is also part of chaos engineering. Then the next question might be, why would you want to do that? We are already testing. We don't want to kill our production environments. Why would you bring in more chaos than it's already there? One of the biggest reasons is chaos is inevitable. It will come, and it probably will come in areas that you don't expect. People are saying, but we have unit tests, we have integration tests. Yes, but these tests are reasoned about, and chaos can really bring up other issues. It's also about creating mindsets. You know, when you start talking about chaos with engineers together, it creates a mindset of We know people will start doing experiments, so maybe we can already make our systems more resilient before we even start experimenting. So by creating a combined mindset of building resilience, you're already creating a better system. And it's also a thing that when you start working with chaos engineering, you are going to discuss with your team about chaos. You are also learning your system. You get a better understanding of your system. Like when you have a distributed system with many microservices, it can be quite complex. And when you start talking about scenarios of how to try chaos engineering, you get a deeper understanding of your system. These are all very valuable outcomes of chaos engineering without even breaking a single thing. It's just a discussion only already helps. One of the things I also remember, and I don't know if that's maybe because as I'm already 40-something years old, I'm kind of old as an engineer maybe, but I remember that many times we had issues with backups. People in the office, you had a backup strategy, they worked with tapes, they back up every document, and when something broke down, we wanted to restore backups, they always fails. All the time they say, no, it doesn't work because whatever reason. And I think maybe the biggest part is because they never tried it. And that's what you are going to do with chaos engineering. You really try if your hypotheses are true. You are going to break things. And you are going to test in production at the end if your software still works, even if you remove certain services, certain parts of your system. So that's a really good part, a good argument why you want to do chaos engineering. There's another good example that I remember is a few years ago we had an issue with NuGet. The NuGet servers were down, and it's something you never think about. You have unit tests, you have your CI/CD pipelines, but the problem was because the NuGet servers were down, all our pipelines failed because they couldn't restore packages, and that's something you might not think about when you're talking about production. You want to put your software in production, and somehow you can't because NuGet is down. Well, I'm not sure if you would find that issue with chaos engineering, but it is chaos. It is a scenario that can happen, and if that's the case, you can't put anything in production, then you can have serious issues. So it's good to reason about all the issues that can come up and what to do about it. Well, there are some business values. Actually, you also need to discuss. By creating more reliable systems, you create business value, because if you talk about service level agreements, putting things in maybe into data center can really improve your reliability, can really make your systems deliver bigger business value too. So the availability percentages can go up. Another thing is debugging. Just like Lila said, debugging systems is way too complex. Testing can help, but testing is normally you have some very reasonable test scenarios. But a test scenario normally wouldn't say just remove a product service and let's see what happens. And that's what you're going to do. So it's kind of the next step of testing your distributed system as a whole is chaos engineering. And the last thing that's stated there, the emergent issues, maybe you kill a service, you say, okay, I have a product service, when the product service is down, I use a cache. And you test it in production, and you can find something completely different. Or what I said, maybe the warehouse is also using the product service to find the location of a product, and you didn't think of that scenario. These emergent issues are very important. You were not aware of them. You couldn't reason about them. You couldn't test them because they were out of your radar. Experiments might fail in unexpected ways, so you should be prepared if you do it in production that you have to roll back because something happened that you just didn't expect to happen. It's good to have that in mind too. So we are kind of making it more practical right now. And the first question is, but how can we start? Well, the first thing is start small. That's like with everything, start small. And start with involving everyone. And one of the things that I didn't think of in the beginning was, why should I have a UX designer in my chaos engineering team? What he is not a developer, not an engineer, that he knows about services and stuff, but actually it was very valuable to get UX people in the room, because you are going to talk about scenarios. Let's say you have Netflix is having this top 10 of movies, currently the top 10 in your country, and they are saying people should be able to watch movies, but this top 10 bar on your screen is not that important. We can remove it if something is broken, and that's something you can use a UX designer for. How can my website look like if something is broken? What if cross-selling fails? What if the login fails? What kind of messages do we show? All these kind of scenarios are also very important in your case. You can't just start showing error messages, sorry, something is wrong. No, that's where you get UX designers, front-end designers also in the team. They also might think about different scenarios, different fallback scenarios, better messages, better experience. Also, it's very important to have managers, to have your stakeholders involved, because maybe you think a certain part is very important. Well, they might say, no, well, this part, if it fails, it doesn't really matter. We can just remove it from the website. As long as people can still order, I'm okay. It's kind of finding a balance between cost and damage control, so to say. So, well, as I said, start small, think about the blast radius, don't kill your whole system, and start locally. Don't start in production. As they say, the unicorns, they are doing in production, and at the end, maybe you should do it in production, but it's not the first goal. Just start small. Start on your development environment. Maybe start on your staging environment, and when you have everything in place, maybe at the end you can do production. But it's not the start. You can't just start killing services in production. One very important part is convince your management that it's a valuable tool to start to use chaos engineering. And maybe they find it difficult, but chaos will come. Chaos is always there. There are always issues, there are always problems, and it's good to start testing these issues. Plan controlled experience, and there's nothing better than just do it on office hours. You start 10 o'clock, everybody's awake, everybody has coffee. Just start doing some experiments instead of being called out of bed because there's an issue while somebody did a release in the weekend. No, you can just do it during office time. Again, start small, so you can start talking about canary releases. Maybe only 5% will have issues with chaos. All the other people are just, that traffic is redirected to the normal systems. So there are strategies there to help convince management that no, not your complete business will fall down, or we just take a small part and we test them. As I said before, add them to the experiment design, help them get involved. Let them think about what is really valuable, what parts can we maybe skip if there are issues. One of the things I sometimes ask is, would you rather improve your system and just by let's just start talking and improve your system? Would that be? Would you not prefer to have these kind of discussions instead of finding out that maybe something breaks when we do releases, or maybe in the weekend, or these? You can plan ahead for chaos. Don't you want to plan ahead for that? And many times it takes time for management, for stakeholders to really allow you to do it in production, but it's very good to help. Well, these are some of the things you could discuss about. So what scenarios could you think about if you think about chaos? Well, there are many parts where you can start. These are some of the most used, maybe the easy parts. So you can start with maybe traffic, maybe load, network issues, hard disk failures, host failures, just remove some hosts, things like that. There are a lot of tools to create these scenarios. There are too many to call out, but a few like Chaos Monkey, Chaos Mesh, Gremlin. There are some .NET packages which I will actually show later on. But there are a lot of tools who can help you with create unreliable networks or exceptions or other behavior things. Some of the tools are actually very simple. You can just use Docker stop or kubectl remove just to remove a service and see what will happen. So you don't need fancy tools. You can do it easily with some easy tools. Region evacuation, that's kind of a cool thing. The story goes that Netflix does that at least once a month. They will just completely shut down, or let me just use the word shut down, a complete region, because they want to test if that's giving them any trouble. They just kill a complete region and another region will pick up the traffic and you can still play your videos. DNS outages is also a nice thing. I have some more scenarios here which you can think about. And one of the fun things there is people chaos. And in the beginning, I never thought about people chaos, but I think we are all familiar with the term, the buzz factor. You have one most senior guy in your team who knows everything. If something is wrong, you'll just ask him, he'll fix it. So what you should do when he comes to the office, just tell him, please go home. Don't put off your phone, but you're off today. We don't need you. And see what will happen. Can your team manage anything without this guy? What happened? You want the team to also know that it's not only about systems, but the buzz. Actually, if he doesn't pay attention and you have a real buzz factor, you have an issue in your team. That's also chaos. So that's one thing to try. Just send somebody home, see what will happen. A very fun thing to do is plan game days. You just take a few people from a few teams, you sit together, as I said, start 10 o'clock, grab a cup of coffee and start experimenting. And it's not only that it's good for your systems, it's also good for your team. And I can imagine if you do this, you can really have a lot of fun, especially when you do it in production. It can be scary in the beginning, but it's very cool to do. Because if you plan ahead, you have tested it on all your environments. Why shouldn't you do it in production? But again, be careful, plan ahead, design your experiments well, make sure you have fallbacks, and execute and document the results. If you don't document the results, you don't have anything, no outcome of your experiment. So it's good to document and to share it with your organization. Maybe just tell them that you did a game day, you did this and this experiments, this was the outcome. Maybe you solved some issues, maybe you found some new issues. And it's also like kind of practicing. If you don't do it often, people might not know how to do it. The same goes for when chaos happens for real. It's also kind of a practice to have game days, like firefighters, they practice. Why do they practice? Because if something happens, they know how to act fast. So by doing game days, you also create some muscle memory for people to really solve issues when something happens. So it's a very fun thing to do. Well, let's start with the fun part then. Bring in the real monkeys. Demo time. Before I start, I want to show the design of my application. I created the Chaos Monkey Pizza web shop. It's kind of a simple web shop. It has a web application. It has 3 services: product service, cross-selling service, and order service, all with their own database. And that's it. And I think if I ask people, can you tell me some weaknesses? We can find at least 10 right now, because it's just not a resilient system. How does that look like in production? I have a website here, which doesn't really look nice, but it's just the idea. I have products, I can click on the product, I see the product, and I get some cross-selling products. So if I want to order a pizza, I can also get an appetizer, a drink, and a dessert. I have a cart, and I haven't really made it that well, so the cart is just a random number of products for which I can just place an order. It will give me my order number. And then if I'm correct, I can find, yes, my order has been processed. Going very fast. That's my website right now. So let's start doing some experiments on this website. Oh. Let's say, when we kill the products database, so the products database is unavailable. Customers can see all the products and the information and still order pizzas. So basically, when we kill the products database, nothing goes wrong. Well, let's do that. But let me just, before I do that, let me just show you, I'm using Kubernetes. My font is too large. I have a web service. So here I have a web service, orders, products database, cross-sell, and a cross-sell database. This is products database, and orders. So there's nothing fancy there. Okay, I'm going to scale down my products Postgres. So what it does, I don't know if you're familiar with Kubernetes, but what it does, it says, I want from the products database just 0 replicas, which is basically the same as killing, but if I kill it, it will restart, and that's not something I want. So I've killed the products database. Let's see what happens. Well, too bad, it failed. So my experiment has failed. So what can I actually do to solve this issue? And I'm going to do something which might look a bit complex, but I'm going to do a retry mechanism. So it will retry a few times. But then there will be a circuit breaker, which I'll explain later with the products cache. How does that look? And so when I get products, is this circuit broken? No, it is not broken. Okay. Did I receive successfully some products? No. Are there too many exceptions? No, then I will retry. So that's the first step that will happen. It will start retrying 3 times if there are products. If I did successfully receive products, it will store products in the cache and show the products on the website, and it's done. Why am I storing products in the cache? If something happens with the products service, I can use the cache later for other scenarios. So maybe if there has not successfully been any products, there are too many exceptions, I will break the circuit and I will get products from cache if they are available. If not, well, I don't know what scenario I would come here, but for now I will just say, okay, then sorry, but I can't fix your system. But if there are products from the cache, I will show products. So how does that work? Let me just show you some code. I created an in the website, I have created a product service factory. So this is a minimal API. And oh no, this is not a minimal, the service is a minimal API. I have a product service on the index page. What it does is I have a product service factory which gives me a product service. And there's a setting there which says resilience enabled, yes or no. Let me just show you how the service looks like. Product service factory. If the product service is just telling me, okay, it's resilience enabled, then I want a resilient variant of this product service, and otherwise I'll just return the normal product service. Just show you how this looks. Maybe I won't get into details now, and I'll show later. There's one very cool thing I wanted to show, and that is what I'm doing here is I'm using something called Azure App Configuration. If I go to the website, I can go to settings and I can see the settings of my application. And actually here it is saying resilience enabled is false. So I can just enable this setting and there will be some kind of resilience. What I do then is I go to Azure App Configuration, and there I can Configuration Explorer. Let me zoom in a bit. These are all my settings from the app settings file. Show the values. And I'm going to enable resilience. How this works is I can change all these settings, but the application is waiting for me to change one value, which is quickly go here. It is waiting for the Chaos Monkey Pizza Sentinel to change. And as long as I don't change this value, which is actually this one, it won't update my settings. So I can just do some arbitrary thing here. I put it to 49. Now if I refresh, as you can see here, my resilience is enabled. And I go back here. And I was hoping that I would have some products right now, but maybe my cache is not working. It'll take a while before it gets back. Yes, now it's back, so that should mean that if I do that again, there should be something in my cache right now. Yes, so just to prove, okay, get. If we look very well, there is not a products Postgres anymore, so it's running without the database. And I can still order pizzas. Well, that's the first one. So what we have now, we have a more resilient product flow by just adding a cache and a circuit breaker. And I heard other people talk about the circuit breaker and the retry mechanism, but I will still explain a bit about how that works in the products service decorator. What this does, first is there is a circuit breaker, and the circuit breaker is singleton. And the circuit breaker says, okay, I will listen to certain exceptions, and if there are more than, let's say, 6 exceptions, I will break the circuit, and nothing can come through anymore. And what you can do then is you can create a fallback action. So let's say here I have a method that says give me all products. And I have a normal action and I have a fallback action. If the normal action fails, it will go to the fallback and just say, okay, instead of getting them from the repository, I will get them from the, maybe I've just found the bug, right? Oh no, this is true. This is the resilient decorator. So that one will go to the cache. So that's how that works. It will just try a few times. If it doesn't get any product, it will go to the cache and get products there. I created the service like this, a circuit breaker, so I can reuse it for products. I can reuse it for other services too. So I can make it a bit more clear here. I have a circuit breaker that says every API exception or any invalid data exception I will handle. If there are more than 6, I will break the circuit for 30 seconds, which is kind of small, but it's just for a demo. It will also do some logging, well, that's about it. The next experiment is about cross-selling. Cross-selling is less important. We want to sell pizzas, and if people don't buy cross-selling products, well, too bad, but it's not our main business. We want them to buy pizza. So the hypothesis is when cross-selling information is unavailable, customer can still see all products and information and order pizzas, no problem. And that's kind of the same scenario. I'm going to reset the resilience setting. So, reset the resilience, which is here. Back to false. Update the settings. Double check that they are now it's false again. So okay. When I kill my, which one did I kill right now? It's faster to restart the service and get connection to the database back. Takes a while to get my products back from the database. Double check if everything is running. I have a website, I have a cross-sell database products, should work. Yes, there it is. So when I click here, I get my cross-selling products. What happens when I kill the service again? So now I'm going to kill the deployment for the, let me just call this, kill the cross-selling products. Too bad again. Well, it is expected, of course. The outcome failed again. Why is that? Because if you remember, the design of the application is very simple. There's nothing there that hides it from anything. So I have a different scenario. I have a retry mechanism, and I'm just going to hide cross-selling products when the circuit is broken. The only thing is, if you go back here, the cross-selling products, just enable the resilience again, because that's the only thing I need to do, and then I'll show how that works. Yes, I've enabled the resilience again. When I click here, oh, why is that? Settings, chaos, resilience enabled. Something is not right here. Let me quickly check why that is. Index. and I go to my order page. My order page says, normally when you do this live, people will say, that's chaos for you, which is actually true, but not expected, because I was expecting that this should just work, because I get my products, and I should also have my cross-selling products. Something is wrong here. What I wanted to do, it looks the same. The only thing is I will just hide the flow when cross-sell. Something is wrong there, so I'll just skip this scenario and find out what's happening here later. If that works, I guess that works. Okay, so let me go into a new experiment. Ordering should be possible at all times, because ordering is our main business. We want people to be able to order. So even if the cross-selling products are not available, whatever happens, people should be able to order. Well, it's kind of the same scenario as I had before. What happens if I kill the order service? And I have a very simple order page here. As I said, it's just a random, it will just generate random products. When I place an order, I cannot place an order anymore, which is actually very simple to reason about. I just have a service, and this connects straight to the service. I put this order there, and that's it. So what can we do to fix this? Well, I think normally I would just say, let's add it to a queue. Let's add it to a RabbitMQ cluster or something like that, because it will just put it in the queue and a worker can just process my orders. So let's do that. Okay. What I've done here is the same scenario. I have a order command factory, and the order command factory decides how I'm going to manage place my orders based on the setting use bus for ordering. If I go back to my browser and show you the settings in Azure, I have here use bus for ordering, which is false. So if I just update that setting, instead of just creating orders straight to the database, it's going to do put a message on a bus, and then there will be a worker which will process my orders. It's already in place. I can show you that. Worker 2. The worker actually doesn't do much. It just says there's an order, put it in the database, and well, that's it. So let me demonstrate how that works. Do this on true. And now I can order again, because now it is using a queue. And I will show you how I know that it's using a queue later, but what we currently did is from a very simple system with 3 web services or 3 microservices, we have evolved our system just with a few experiments with this. It's already growing. We added a cache. Here we did nothing, because we said if cross-selling is failing, we just remove the products from the website, and that's it. The other services, instead of directly using it, we put them in a queue. They will be processed, they will be put in a database, and we can still get the order information on the website from the service. But if the service is not available, I cannot get my status, but I will still receive my pizza. if you looked very carefully, you already saw the activity, and maybe that reminds you of a session you had just had the session before, because there Laila talked about activities. What I also did is I am also using OpenTelemetry with Jaeger. So what I can do here now, I can just see, okay, can we see some of the traces? And there will be a few, like this one has an exception because I killed the database. Maybe we can see somewhere where the exception is. Error is true. There might be some information, but it's not really interesting because I was expecting this. What I wanted to show is a successful trace now, which has 10 spans, where you can actually see that the message has been going from the website to the order worker, from the order worker back to the website. So that's how I know that it has reached the event bus, or the RabbitMQ in this case. Okay, so this is my current system now. Well, it's a pity that my cross-selling is not working, but I don't think that will affect my other demonstrations. Because what I wanted to show now is some .NET packages which can actually help in creating some monkey behavior, just some randomness, just to see what will happen, because it's actually fun to do. And what I'm using is a .NET package, Simi. Simi is from the same family as Poly. Poly is the policy part we just discussed, so the retry mechanisms, the circuit breakers, they are using Poly, and Simi is to create exceptions, latency. It can also do some behavior or some actions before something is happening. And exceptions, I think that's clear. You can just say, okay, just throw exceptions. Latency, well, it's also clear, but behavior and actions are a bit different. With behavior, you can just do something different than you expect. So maybe you say, give me products, and this Simi package can just return some cross-selling products, just to really make some monkey behavior there. Or you can delete the database before you can start querying the database, just to see, okay, how would your system react if you delete databases? Let me go back to my settings here. I have maybe I show them on the website first. I have some settings here. Let's show you the product service. I have not enabled chaos, so let's start with enabling chaos for the product service. Product. Let me do it first. And then the next setting is the injection rate, and 0.5 means 50% of my traffic will end up in an exception. Well, that's kind of high, so let me just put it on 30%. And I think that's enough for now. Let's start there. And let's disable resilience first. Just to see what will happen. Refresh to see if everything has been done. So now my chaos is enabled. 0.3, so 30% will receive exceptions, no resilience. When I now go to the home page and just click a few times, you'll see sometimes it works, sometimes it won't. Okay, now when I enable my resilience, and the resilience enabling means I will have a circuit breaker with a retry mechanism, and if all fails, I have a cache in place, which hopefully will have some products in it. And now, well, that's kind of hard to see, but sometimes it might be slower, but there will be no exceptions anymore. So I have a more resilient site. You know, here you can see it. Sometimes it's very fast. Sometimes it takes longer to load. Then it might be retrying 1, 2, 3, just a few times. So that's the exceptions. I can also show you, because I'm using logging, I can also show you how that looks. you'll just see here a few errors, application error, and it here is saying, I'm just throwing an exception, monkey says hi. And how does that look like? Just go to the products service. And what I did there is, this is a minimal API. I'm requesting all products, and I have two different repositories. I have either a normal repository or a chaos repository. I'll show the chaos repository. The chaos repository has policies. So this policy is, I will inject exceptions. It will throw an invalid data exception with a message chaos says hi with the injection rate I just explained, and I will enable them all. I could have added a different variable here, but just by just putting the exception rate on 0, also puts it on disabled. So that's kind of double, and I had another parameter already. The latency I didn't show yet, but I will show. It's just going to throw in some latency once in a while. Let me just enable that quickly. Products, latency of 300 milliseconds. I could have made it random, but I just decided to do it this way. And well, I think actually I already enabled it. Disable the exceptions and just add the latency. Let me check my time. Still okay. So like this. And now nothing will happen because my retry mechanism will just catch every exception and it will just continue. So that's all fine. But what I did in the website is I have a timeout of 500 milliseconds. So now everything will happen, but what will happen if I change my latency of my product service to 550 milliseconds? Now it's 550 milliseconds. Now you'll see normally it will just work. And it will keep working probably because I have these retry mechanisms. So it will just restart 3 times, nothing will happen. If I'm updating the injection rate, so let's say 80% will have a latency, then it will be a different story, because now maybe it will not, the challenge is there that every call has more than 500 milliseconds. It's still okay, it's still working. Now, if I really want to break it, by all means, I can just put this on 100% will have latency. I think it should break. Maybe it's getting my products from the cache. Anyway, you see that's the difficult thing is you might have so much resilience already that you forgot what will happen already. And when you reason about it with your team, maybe somebody would have told me already, maybe one of you is telling in the chat, but of course it's working because you enabled resilience. And maybe it will use the cache. So that's something I didn't think about right now. There are other things we could do. We can also say, well, let's just kill pods randomly. I could do that. Let me just do some random. And I created some custom scripts myself because I didn't want to use any tools. They are quite complex to start with. So what this does is just, it kills services once in a while, every 30 seconds. So now the order of service is killed. It can also help in, but still the resilience is enabled, so nothing will go wrong right now. Just enable this, and it will fail. Yeah, now it will fill Let me just bring the resilience back to maybe 20%. And now I will get exceptions once in a while when things break. But that, I'm not going to wait till products. There you can already see it. So that's chaos again. Okay, so let me just stop there with the demo and just do a little recap of what we just discussed. How can we start is what many people ask. They don't want all the theories about it, but they just want to start. So start small. You can start on your own machine. Just start playing with resilience. And if you are a .NET developer, you can start with Poly to create some policies. You can did the same as I did with Simi. I have some links at the end, so you can play with Simi just to try on your local machine. Then, when you have done things on your local machine, then you get your team involved, do something on a testing environment, on a staging environment. Don't do it in production, just start small. Get everyone involved. I can't state that enough. It's very important to have everybody on the table when you talk about resilience, when you talk about chaos, about experiments. They have different angles to look at problems. They have different ideas about how you can actually solve issues, fallback scenarios. The third part is very important, measure. You need to measure a lot of things. And also, don't forget to measure the state of your other tools. One example, I didn't talk about that yet, but one example was, let's say you have a PagerDuty. PagerDuty sends you a message when something is wrong. But maybe when you are doing chaos, you kill the line to the PagerDuty, and nobody will know that something is wrong. So if you don't measure everything, it might be possible that you think, okay, I have my dashboard, everything is green, but still things are broken. So you also need to test some systems you use for testing. Don't forget that. So be aware that you might kill things that are actually helping you to see if everything is working. Plan ahead and think about abort conditions. When do we stop this experiment? How do we stop this experiment? Are we sure that when we stop the experiment, everything will work again? One of the things I just had with my demo, I had it multiple times. When my database is coming back online, it takes a while for the product service to have a new connection to the database. It's actually something I need to work on, but well, it's chaos, so I don't care. I have it on my backlog. I will fix it later. But yeah, you need to be sure if you abort, will everything work again? Maybe you need to restart some services to get connections back to the database. Plan ahead, test it before you do it on production, test it on your staging again. Think about blast radius. One of the things that's also important is, let's say you have an API, you sell data to customers, and you are going to start with chaos engineering, and you did not think about your customers. Maybe they can't get connections to your system. Then you are in trouble. And you can say that maybe they also need to start working with chaos and they should build more reliable systems. Yes, maybe they should, but you can't just expect them to do that without knowing you are doing it. So think about blast radius. Discussing about experiments already helps. That's maybe the best start you can make with your team. How can we create things more resilient? What is resilience? What is reliability? Have a discussion about what that is. That already helps. If people have it in mind, they will actually develop better systems. And some of the tools I've used, well, Poly, Simi, Azure App Configuration, showed them all, SAC for logging, Jaeger, Kubernetes, OpenTelemetry, RabbitMQ. I've not showed RabbitMQ, but it's there. I've used Rider, and maybe there were some observant people who saw that I have a different operating system than many people. I'm using Arch Linux. Well, and I think that's the end of my talk, and I think I'm 2 minutes early, so that's okay. Thank you very much. If you have any questions, you can ask them after the session, connect me, and thank you very much for listening.
All right. I'm keeping your slide up for a little bit so people can find your blog and Twitter and all of that. Thank you, Jacob, for a fantastic talk on chaos engineering.
It's great.
There are a couple of questions, but before we dive into the questions, we've actually been doing a poll at the start of your talk, asking people whether their company is currently doing chaos or reliability engineering or is planning to do it. And 71% answered with no, 24% with no, not yet, but we will. And only a couple, like 6%, answered yes.
I'm not surprised.
Is that what you see with customers and all
yes.
of that?
Yes, yes. In fact, it's like when you look at developer conferences and things, it seems like it's grown, but it's not really popular yet. Many people, and I think it's something developers really like, but it's very hard to convince your management. Management is really afraid of things like this. That's something I see, and you know, there are so many tools and there's so many work. It seems like it's the last resort, chaos engineering, which is actually not true, but that's the same for unit testing. And still, people don't unit test. But yes, I'm not surprised.
So is that the major blocker then, just that people think it's too complex or it's too hard to sell to management, and management just tends to go, no, we don't need that?
Many times, yes, especially when you say, well, we are going to do some chaos engineering on production, then you just have a difficult conversation. And that's why I say, don't use the name chaos engineering. Talk about reliability, resilience, use different words. And as I said, game days is just fun to do. Start with that and just start very small and show them that it works. Just tell them, come in the room. We are going to kill something in production. Watch it happening. And they need to build trust, you know? So they should trust developers that they know what they do. Yeah, so just show them.
Well, along with that, somebody asked if you're the only engineer on a team who sees the value so far, is there a minimal chaos engineering setup where they can kind of ease the team into it and maybe get other team members on your side and then present that to management? So if we have some kind of minimal setup that you would suggest people to start with, maybe a single machine, because you mentioned doing a little bit in your development environment, something like that, perhaps?
But that's I think that's the most easy start. Start on your local environment, and maybe show your teammates that look what I did. I can just kill service and still things are working. And I wouldn't be surprised that they will really like to see that, and they will start experimenting themselves, and just from bottom up maybe get more and more people involved and more systems involved, and go into staging, and then maybe finally even production. So I think it's starting small from the bottom.
I think related to that, would it make sense to also talk to stakeholders like the sales team, like maybe the support team and so on, to say, look, if we unplug this server, we won't have any orders for the day. We want to see what happens when we do that, but we also want to improve on that. Is that like a discussion that is easy or a good entry into the team, or?
Yes, and it's sometimes you can start small. You can explain them that, like, what is red-green deployment. Even thinking of starting with Kubernetes can really help in telling people, if you do red-green deployment, when we do a deployment, nothing will fail. That's kind of chaos engineering already, although it's very small. That's a good start. If you show your management, your stakeholders, that look, we can do deployments while everything is still using the website, orders are still going on. Maybe we can go to the next step. That's just kill a service. That's the same thing. And then let the experiments grow and grow and do different experiments.
I was just going to ask about that. Like, if you start, would you start in code, like adding random interruptions and things in there, or would you just start with killing random containers on your Kubernetes cluster and seeing what happens?
Well, maybe I locally I might start with killing containers and see what's happened, but maybe I will look into some tooling. If you look like Gremlin is actually a great tool, which can also use health checks, so it can verify if everything is still working, which makes it more professional. Well, no, I think I will start with killing services locally. That's maybe the first thing I would do. But the funny thing with these tools is you can do things like having full disks or having DNS issues or things like that. So that may be kind of a mix. Start with killing, but very soon start using some tools.
It's always DNS anyway.
Yeah, we blamed it right at the start of the talk. So somebody asked, I like this question. Is it worth doing this type of engineering if you don't necessarily want to automate the recovery? Perhaps checking that your recovery process is documented sufficiently or some other reason that isn't necessarily recovery. Are there some good reasons for doing it outside of that?
I think one of the main reasons is finding emergent issues that are out of your radar. It doesn't have to do with how you get everything back up running, but finding issues you didn't think about. Because the things you thought about, probably you have unit tests around them, probably you have integration tests around them. It's the issues you didn't think about you want to find. And it's not about getting things running again, but finding these issues and discussing how do we solve it? Do we actually solve it? Maybe business says, well, it's a rare issue, it's too expensive, leave it. That's also an outcome.
Yeah, maybe a related question there as well from the audience, and that was, is chaos engineering relevant in environments that do not rely on networks?
Are there even systems that do not rely on networks anymore?
I was wondering the same thing, but I guess it probably also makes sense to try those things like having a full disk and seeing what the application does when that happens. And
yeah, I can think maybe you have a mobile application, but normally they also have networks. Desktop applications. Well, I can't think of systems without any external connections. Then you would have a database. You can still think of, but I think it has more value on distributed systems with microservices, with databases. That might have more impact to do it there than on a desktop application.
Okay. Somebody else asked if there were tools that they can use. You did list some on the last slide, but it would be not the big ones like Azure Chaos Studio, but something local for their app, other than just making changes themselves. I guess when you're doing starting out, doing some of your local testing, are there some quick, easy tools to get started in this?
There is. Well, there's like chaos, but there are, I think the problem is they all start small, but before they start growing and adding things and features. So most of them are kind of complex. There are some example scripts, like just the script I wrote it myself, just a simple bash script that randomly kills services that it can find. So maybe it's easier to start your own scripts for small local development and not dive into these tools too much. Chaos Mesh, I found it quite complex. There are too many. Just Google and find out what works for you. Maybe that's the best I can say about it.
That makes sense. For the next question, I'm going to bring Khalid in if he's around. I don't see his camera yet. Yeah, there he is.
There he is.
He has one really, really important question around
it's the
your
most
talk.
important.
So I'm going to bring him in.
Do I? What is my question?
You do.
I do?
It is about the title of the talk.
Oh, am I supposed to let me see. I don't know. You guys like kind of snuck this up on me. Let me see if I can find it. Let me see here. Oh no, I don't have it. I'm sorry. I can't do this. I didn't see it. I was gonna show up like a monkey. I'm sorry. Maybe next time.
Okay.
Sorry, I let you down.
It's fine.
No,
It's fine.
But
I know this was kind of abrupt in bringing Khalid in, but Jacob, again, thank you for your talk. Great talk. I think we are about ready to switch to the next presenter and to the next host. So welcome Khalid as the next host. I will be disappearing.
yeah.
And then Jacob,
Thank
you and
very
I can
much.
go offline, I guess.
Yes, thanks for having me.
Thanks,
Thank
Jacob.
you, Jacob. Thanks, Martin.
Bye.
Thank you. Bye.
See ya.